So we have seen how the B device connect is identified. Okay. The same case, suppose our state machine is working fine with the assumption that B device is connected. Suddenly that J state is switching from that state to some other state, K state. In that case, what will happen? It has to detect that disconnect, right? So during that time also, this always block will work, and it will check whether disconnected or it is remain unconnected. Connected. Okay, so that is a always block related to that B connect device mechanism. Next, SRP detect. As we have discussed earlier, SRP means session request protocol. Okay, so in that two mechanism are there. First one is VBus pulsing. Second one is data line pulsing. Okay, so while B device is sending that VBus pulsing or data line pulsing, it has to detect that one, right? For that I implemented some logic here. Okay, VBus pulsing in the sense that there will be one small pulse in the VBus VCC, so that thing will come in that VBus. Okay, so I have detected here application requested OTG. We know that CPU may do only data line pulsing. We have seen in registers, na? So CPU may come and tell you detect only data line pulsing, right? So if it is that case, application telling OTG to detect data line pulsing alone, or it does not mention anything regarding SRP detection, that case it will do data line pulsing.
Okay, one more case is possible.
What?
CPU tell you take only data line,
Right.
VBus pulsing or data line or VBus.
Right.
Okay, then CPU do not told nothing.
Yeah.
That case,
Yeah, here I mentioned, right? It is not mentioning, it does not mention anything. In that case, it will work in default condition. That default condition is nothing but detect data line pulsing. Yeah. Yeah. Default condition.
okay, we do not know VBus or data line.
Right. No.
In that case,
Our implementation should have some default values. CPU may tell either you should work in default data line state or VBus pulsing state. Okay. But if it is not mentioning anything, means even though also it will work. This is according to my implementation. I implemented in that way. You may implement, if CPU is not mentioning anything, I will not do anything. Like that also you may implement. But here I implemented default state as a data line state. That's it.
that case default.
Yeah. Okay. So CPU has configured me to work to detect data line pulsing. So I am detecting that in line state is there any change. Based on that I will enable my timer. Here also again
That means J connect.
J state is the data line pulsing.
That means B connected or not.
Yeah, for B connect also it will use that J state. Okay, but the timing window will be differ. If that J state is remain for example 5 nanosecond, means if it is satisfying that 5 nanosecond window time, then we can say that that is a B connect signal. For example, this data line pulsing, this is a pulse. It will have only 1 nanosecond. If it remains in that 1 nanosecond, it will take it as a data line pulsing. That too depends on that state diagram. In that state diagram, first data line, this SRP protocol will happen. Then only remaining things will happen, right? First it has to happen, this SRP detection. That's what happening here. Okay, so once it has detected that SRP pulse, next it has to enable the timer. After that I will get a timer done signal. So this is the timer. From timer I am getting timeout, that the timer is over, timer done signal. So I am enabling my SRP detect signal as SRP as detected. Okay, now the next case, application requested OTG to detect VBus pulsing. So far we have seen data line pulsing and default case. Now we are going to consider the third case, VBus pulsing alone. During that time I have to check that V bus state, whether it is having some voltage level on that VCC. If it is having means I will consider it as a V bus pulsing. And at last SRP deduction not enabled or count as not over. Suppose SRP deduction not enabled. In that case what will happen? Everything I mentioned here. Okay. So this always block deals with
SRP detection not.
For example, first
Not
I am getting J
not
state.
enabled.
Yeah. Are you getting?
Yes.
Okay. So far we have seen that SRP deduct logic. Before that we have seen B connect logic. Now we are going to see about resume. Suspend resume, you know concept in USB suspension. When suspension will happen? If there is no activity between the host and device. So it has to suspend that bus so that it can save some power.
Consumption.
Yeah, power consumption. So it will save some power, right? That is the logic. So host will suspend the bus so that it is reducing the power consumption. Okay. So once it is ready with data, again it will send resume signal. So it has to deduct that resume. Everything is happening over the D plus and D minus line.
Okay. My question is, there is no working host and device.
Yeah, between host and device, no transaction.
No data transaction. That time a power consumption in device.
Right.
Device part. That means but
No,
don't
no,
work.
no. Actually, during that time, for example, actually it is consuming 1 milliamps. Normal transaction, if it is consuming 1 milliamp of current. During the suspend state, it will consume power, but it is very, very less. For example, point.
Like it maintain that 0.2.
Very low. Like that. It will consume very less amount of power. It doesn't mean that it will not consume any power. It will consume, but less amount of power. Okay. So we are. This is again one more always block I used to implement this B bus resume deduction logic. Okay. Again, these are all based on the that line state. If line state signal is K means K and B bus resume is enabled. Already it is in enabled state. If there is any resume signal, I have to detect. Like that, someone has ordered me. That is what the signal is indicating. If B bus resume is coming means you have to detect. Someone is ordering through the signal. And in that line state, I am getting K state. K state, I will consider K state as a resume signal. Okay. So K state. Both are